Welcome to Metal Welding Lecture Series by Professor Joyjeet Ghose. This is the 13th lecture of the series. This lecture will be on Electroslag Welding, ESW. He will be discussing about Electroslag Welding, ESW principle, Electroslag Welding, ESW, process parameters like current, moulding, shoe, flux etc. Advantages, limitations and applications of Electroslag Welding, ESW, are also discussed, so do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this 13 lectures of a series of lecture on metal welding. In this lecture we'll be discussing another important welding called electroslag welding. Electroslag welding is a welding process which is mainly used to weld thick plates. So this welding process, as I have said, it is used to weld or to repair thick plates which are broken or to join thick plates. So it's a combination, you can say it's an arc welding and resistance welding process. So here we require an arc which is created between a consumable electrode as well as flux. So here first what we do is that the two metal pieces which will be joined is brought near to each other, and then from two lateral side we place a sort of mold, you can say, or molding shoe, we call it, normally made of copper, and it is water cooled. So this is, from this side you have this shoe, and from this side also you have this shoe which is water cooled, and this is mainly made of copper. Dissipate the heat quickly. Now here it is filled with flux. In between it is filled with fluxes. Now when you start the DC current, we normally use DC current in electroslag welding. DC current and ampere is high amperage, normally in the range of around 400, 500, 600 ampere depending on the thickness, and thickness normally we can weld thick metal plates ranging from 25 mm to around 300 or maybe around 400 mm. So it's a suitable technique for quickly joining thick plates. And not only joining, it can say repairing of broken machine frames, etc., etc. So here we have to, as I've said, we have to make a mold between the two metal pieces which are brought in contact or not in contact, very close to each other. A small gap is maintained, very small gap is maintained, so that we can insert this consumable guide and the electrode, and the copper shoe is water cooled here. So fluxes are placed inside and arc is produced between the flux and the electrode, which is passed through this is tube guide. Now this tube guide protects or insulates the electrode, so that electrode does not touch the copper plate or the metal plates. And the arc produces a slag. This slag then engulfs the arc, and there is short circuit between the slag, which is light, floats and touches the electrode. Now once it touches the electrode, the arc extinguishes, but however this slag that is produced is conducting in nature. Now since this slag is conducting in nature, now electric current is being passed, and because of resistance heating, the metal pieces will be melted, the electrode will be melted, and tube guide will also be melted and will be deposited in such a way so as to form a collisions between the two metal pieces which were joining. So this is the basic fundamentals of electroslag welding. You can see here, you can see this is the copper plate, and this is the consumable guide tube, and this is the electrode which is supplied from a spool. This is the power source. This is connected to the positive terminal, this is connected to the negative terminal, this is the control panel, and this is the water cooled the copper molding plates or shoes as you call it, and the flux will be deposited and metal melted from the lower side, and it will solidify and it will reach to the top. So this is the basic fundamentals of electroslag welding, and we use granular conducting flux. Now this is very important. This flux should be conducting, otherwise it is not possible. The resistance heating will not be possible. So it's a combination of arc welding as well as resistance welding, and you can say in the same time you can say it's a casting process also, because we are using a mold to give us shape to the joint molten metal. The density of this slag is less and it floats and extinguishes the arc. So the process parameters, high ampere is around 600 ampere, very high, voltage 40 to 50 volt. So travel speed is around 12 to 36 mm per minute, and thickness, as I have said, from 25 mm to around large thickness of metal can be welded by this process. So what are the advantages? Is simpler compared to other welding processes. Much thick weight steels can be welded. Electroslag welding gives high deposition rates. Residual stresses and distortion produced are low. Disadvantage is that the submerged arc welding is more economical than electroslag welding for joining below 60 mm. So if it is above 60 mm, definitely you can go for electroslag welding. In electroslag welding, there is some tendency towards hot cracking and notch sensitivity in heat affected zone. It is difficult to close cylindrical welds. Sometimes the shoe has to be designed accordingly. The only vertical position is possible because of the nature of the welding. Application welding of heavy plates, forging, casting can be butt welded. Where plates and castings of uniform thickness are involved, or it may, if they taper at uniform rate, electroslag welding has virtually replaced thermite welding, and being much simpler to that of thermite welding. So it is also used for repairing, not only for joining thick plates. So that's it in electroslag welding. Thank you for watching this video.